design pattern. So let's go ahead and start the screen. Stream. All right, so as I mentioned, we're going to be covering the observer design pattern, and there's a third-party library called Green Robot's EventBus. So we'll show you how to include a third-party library in your Android app. Green Robot has a ton of other libraries, and we'll throw some other ones at you later in the semester for embedded database. They make one called ObjectBox, which is really nice. And previously in Android, like when I first started teaching Android, when we did the database lectures, you had to write SQL code. You had to like select all from table, and then you'd have to do this huge string builder in order to kind of stick those parameters in there. And that's kind of a nightmare if you've ever done that on the web. But with EventBox, it's object-oriented, so you get an object, you get some data members, getters and setters, you throw it in there, and then when you're ready to persist that data to disk, you just call save, and it just works, and it's a database, and you can search on it. But anyway, Green Robot's it's a really cool company out of Germany, I believe, and they have a bunch of open source stuff, and so we'll get to there. So we'll talk about this one. All right, so let's define observer pattern before we dive into this. I'm just going to read this off real quick. So the observer pattern is a software design pattern. We've talked about design patterns. You should all know what design patterns are. If not, we'll talk a little bit about it in this class, but go off and look up design patterns, software design patterns, and just kind of read through some of the ones out there. As I mentioned, singleton, facade, flyweight, component, all these you'll kind of recognize if you've ever worked on large code bases. Anyway, it's a design pattern in which an object called the subject maintains a list of its dependents called observers and notifies those automatically of any state changes, usually by calling one of their methods. All right, so what does this really mean? That's kind of the hardcore definition. Doesn't really make a lot of sense if this is the first time you're seeing it. So we have an observer kind of in the middle here that cares about this subject. So whether the subject is another class or it's just something that's going on in your application, you have another class or object that cares about that subject matter. I'll talk a little bit about more concrete examples, but let's run through this really quickly so we can move on to the code. We have this concept called low coupling, high cohesion. Now, again, if you're software engineering, this is kind of our holy grail of proper software engineering, is we don't want to have all these connections to all these different components, such as these servers and these switches and on these racks, because your code kind of looks like this if you've ever dealt with a large code base, and it's really messy. And just imagine taking one of those computers out of the racks and trying to even just like swap positions of those computers. It's a nightmare because you're trying to deal with all these wires that just get in your way, let alone the ones that are connected, and then trying to trace the wire through to where it's actually connected to. So you can see this is almost a perfect metaphor for our code if we don't use design patterns, which is, again, what we're trying to teach. All right, so what does low coupling, high cohesion actually mean? Well, high cohesion refers to the degree which functionality belongs to a class. So, for example, if we have a car class, as part of that functionality, the car drives itself, right? You don't have necessarily a driver object that makes the car go. He or she might input data to the car in the form of acceleration or turn left, turn right, use a blinker. Hopefully all using your blinkers, right? And so then you have that responsibility in each one of those objects. You have a driver object, you have a car object, and so that's what we call high cohesion. And the low coupling means that you don't necessarily have to know how the pistons or the brake calipers work in the car in order to drive it, right? And so oftentimes you'll see really bad code is the equivalent of a driver understanding and having to physically push the calipers against the brake discs in order to brake the car. That's ridiculous. You should have some kind of interface, which is a design pattern, to that car, namely a brake or a gas pedal, to do those things. And then how the car does that is up to the car. Whether you have an electric car or a gas car, sometimes the brakes work a little bit differently. The electric cars use partially use like an electromagnetic brake, etc. But you don't need to know that. You just need to know this big pedal is the brake. So that's what we're trying to accomplish in our code. Is again, we don't want to have somebody who's working on the person object have to know how to brake or accelerate the car or how pistons work and all that fun stuff. So we want to keep code kind of as a black box, sort of. There's some drawbacks to that, but we'll get to that. Okay, so specifically, how do we solve the issue of trying to decouple two objects but not have so much coupling with them? So again, high cohesion, low coupling. So this is EventBus's diagram for how they, I took this off their site, but how they accomplish this. And so again, we have EventBus, it's an object, it's a singleton, which is a design pattern. So only one ever exists. That's what a singleton is. You only have one because one instance, yes, thank you. One instance of it, though you can kind of think about it if you just want to create like a static class, that kind of works the same way. You don't necessarily have to instantiate a class to get the pattern of a singleton. There are some drawbacks with using singletons. I heard somebody say the other day, friends don't let friends create singletons, but I'll show you why they're really good. So of course you can overuse a lot of these patterns if you're trying to fit a square peg into a round hole, etc. So use these sparingly. I'm just going to show this to you, but we have a EventBus, which is a singleton in this case, and we have a publisher. So this publisher, let's use the YouTube analogy, where we have a YouTube channel, and that YouTube channel, it has content creator. Let's just use myself. I am posting content, right? And I'm just posting it to YouTube, which is the equivalent of EventBus in this. So every time I upload, I'm posting a video. So we go from left to right to YouTube or EventBus. And then anybody that's subscribed to that channel gets notified of that video. And so if you get sick of my videos or you just don't like the content or you get tired of my voice, you can unsubscribe. And so when you unsubscribe, obviously you don't get notifications anymore, but then maybe you change your mind and you want to subscribe again. So maybe you're going on vacation or whatever, so you unsubscribe, then you resubscribe. And so this is the analogy that we're using in EventBus. So you have different objects that care about some type of event. In this case, posting of a video. You can observe different YouTube channels. You can unsubscribe to the ones you don't care about. You can unsubscribe to all of them. And if you die, then you don't get any notifications. However, your YouTube channel or your YouTube account is still subscribed to that channel. So actually, we'll deal with these zombies here in a second. Not to get too, I don't know, mortified here. All right, so we have a subscriber. Let's use our main activity. And we have an onCreate function, and then we have another function called onEvent that we're going to get called back on when some child activity creates an event. So we have an intent that links the two, onCreate in the child activity as well. And then at the bottom for the child activity, we have register event that we're going to post our event from our child. And that's going to get back to our main activity. So if you remember from our previous lectures, when I wanted to pass information from our child activity back to our main activity, we also used the intent. So back and forth, we were using intents. And I said, that's okay for basic data, but you don't want to do this for larger pieces of data. And that stays true with EventBus. You don't want to be passing large pieces of data, though you can, and I'll show you how to do that. But usually it's a better idea is to pass just a little bit, enough information so that the observer who's caring about these events can then go off and look up the larger piece of data. So if you're passing images back and forth, that's probably a bad practice. But if you're just saying, hey, this record with a name and email address was updated, then you can. That's not too big. All right, so here's one example of what your app might look like without the observer pattern. So you have you have a main activity, you have a couple child activities, and then you have another class which does something else, not necessarily an activity. And you have all these different connections back and forth. The main activity on the left-hand side needs to know and interact with the child activity class, and then 3 instances of this other or another activity class. So we have 2 classes, 2 child activity classes. So anyway, it's pretty messy. And that's just a small application too. So if you're just starting out, you probably have done this, and it's fine for small ones. But let's jump into the code really quickly and show you how to solve this. It's pretty easy. This is how we install all third-party libraries, though you can install a jar file if you want to, but I always find that's kind of a mess because you have to download the jar file. Well, first you have to go find it, make sure you get the right version. This one, you just write 1 line of code in your Gradle file, say implementation org.greenrobot : EventBus, and then you can specify the exact version of EventBus, or you can just say get me everything under the 3.0 or 3. Whatever, 3.x, and that would include if EventBus comes out with 3.2, this would automatically get it would get updated when you refresh it, when you refresh your Gradle file. That could be problematic because if they remove something, then you're using that, it'll cause issues. So what we talked about at the beginning of the semester with their dependencies and over relying on dependencies. So introduce these pieces of code sparingly if you can. All right, so then we have to, when I post a video, that is our kind of our object that we're posting. In EventBus, we have events. So events are just classes. You create kind of this class that just holds a little bit of data. It doesn't actually have to have any data, but what defines the event is the class name. And it'll get instantiated and passed back and passed all throughout your application. So just in this case, I just have a variable called payload data. It's of type string. It's an optional, which means it could be null. When I'm posting an event, that might be filled in. It might not be. So that's what we mean by optional. So do a null check on it. We want to register, so this is the act of subscribing to a YouTube channel. Well, I am a register, I care about an event. So EventBus, that's the class name, and then in order to get the singleton, we just do get default. So anytime you see an Android, get instance, get default, that's getting either a singleton or a default instantiation, which means that in EventBus you can actually create your own specialized version of EventBus, but we won't go too much into that. It's just you can create priorities to events, which doesn't make it an observer pattern anymore. It actually makes it an event queue, which is another design pattern, but we're not going to get into that. And then finally, we need somebody to subscribe to that event. So you can do this in your onStart. And then every time your application or your activity gets started up, you'll register for this. So just in your onStart, we have EventBus get default and then .register. So that's what that is. And then we need an event to pass back and forth, or excuse me, to pass to the EventBus and then broadcast out. So we create an instance of that event from whomever. In this case, it would be me creating this event. And I'm passing it a string in the constructor, just whatever that payload data string was. And then I say, hey, EventBus get default, so that one object dot post, and I'm posting that event. Okay, so nowhere in here do you see any implementation of the main activity or the child activity. It's just I'm creating this event, I'm posting it up to EventBus, and then EventBus keeps a queue or a list of all of its subscribers, just like YouTube does. Okay, and then we want to make sure that we unregister it because, again, if we're trying to talk to objects that said they are registered but they're no longer or they no longer care about it, or they're dead, meaning they're deallocated, then yeah, then we want to make sure that we unregister this. Okay, so I think we're good here. All right, so let's go ahead and just jump into our code to show you what this looks like, because we're gonna have to set up the UI for this. So this is kind of a real quick review. So actually, let me go ahead and set up my other class. Gonna right-click, go down to New, create a new activity, and empty activity. And I'm just going to call this 1 second activity. Everything looks good there. Okay, that'll create my layout. It'll put that entry into the Android manifest file. We'll add this to Git, so this goes up on the repo, which is, I'll link to it in the video's description if you don't have access to it.
Are you live streaming this?
Yes. So you don't have to copy it down. Question was if I'm live streaming. I believe I am still live streaming. Let me double check. Okay, good, thanks. Somebody's listening in the classroom with headphones. They prefer the 30-second delay then. Okay, so let's go to our main activity. We have a text view here. I'm going to drag in a button to launch our second activity. Okay, I don't know why I did that. Drag in a button. Okay, so dragging in the hierarchy, I'm going to convert my constraint layout to a linear layout, and then have to select it again because it always deselects it. And do a vertical. Okay, so we have these two. Hello world needs an ID, so I'm just going to call this text view. All right, so what's going to happen is I'm going to hit a button, it's going to launch a second activity, I'm going to type something into an edit text, hit another button in that second activity, and it's going to fill in whatever I entered in that second activity into this text field. Okay, so let's go ahead and do the layout for this one. We'll clean up that layout in a second. Let's convert this over back to a linear layout. As you can tell, I really like linear layouts, and I have to select the linear layout. Orientation, vertical, and then drag in just a plain text here. And then this will be a horizontal layout. Let's do that. Add a button, just going to add it in the hierarchy. I'm going to call this post message button. Say for our edit text, we want to get rid of this pre-filled name, plus it gives me a warning down here, so that's hard-coded. If you leave that in there, then the user has to delete it, so just never really have data in there. Instead, we're going to put a hint, so in this right-hand text field here, we're going to say, I don't know, your message here, something like that. It's poor wording, but actually I'm going to change what I say. I'm going to change this to horizontal. And we're going to wrap the content. And then for my button, I'm going to change the layout weight to 1, and then my text view layout weight to 2. Oops. Did I do that? Oh, okay. Mess around with this a little bit. Something like that. I'm not going to mess with too much, but this one, our text buttons, we're just going to say post. All right, so we're going to type in something in this message, hit the button, and we're going to dismiss this activity, but then we're going to post that event to EventBus, and then it'll magically show up in our main activity. Okay, so I think we have everything. Let me just double check the IDs. Edit text, that's fine. And in our main activity, oops. Okay, that's fine. We'll get to it there. All right, so the first thing we want to do is we want to get a reference to our button so that we can put a click listener on it so we can launch our second activity. So I'm just going to say our button. And for intents, or excuse me, for buttons like this, Alt-Enter to import that. I prefer just explicitly putting the class there, r.id. That way we don't have the templating format, it's just cleaner. For this button, what do I call that button? Just call it a button. Okay, once we have the reference to that button, we can set the onClick listener. Okay. All right, so the onClick listener, we create the intent. Oops, that's not intent. Import that, Alt-Enter. And then for this intent, it's going to ask for the context. That's the activity that we're in. And then for the class, we're going to use second activity. And then remember double : class.java. And again, that's going to pass a reference to that class so that our activity manager can instantiate the activity for us and handle it and put it on the stack and all that fun stuff. All right, then simply just do start activity and pass in the intent. Okay, we're not going to pass any data to the second activity at this moment. All right. Oh, one more thing I forgot to show you the website. So if you find a third-party library that you want to install, I should have done this before doing it because it takes a second to install, but you can kind of read through and see, yeah, this code looks pretty easy. This is all the stuff from the notes. But what I want is how to install it. So just copy that, go to our Android Studio under Gradle scripts, and then select module app. Oh, sorry, it's the entire app. No, wait, that was right. Scroll down, as I say. That was the wrong file. There's 2 Gradle scripts. That was right the first time. And then somewhere in here, doesn't really matter if you want to keep this organized. Great, I'm going to put it at the bottom. Just paste that in. You can see what is all the other libraries that your project is including, the app compatibility, etc. So I'm going to type that in, and then you're going to get this yellow bar at the top. Click on Sync Now, and then if you look at the bottom of my screen, you'll see that it's doing a bunch of stuff. It's installing, it's downloading that jar file for me, handling everything like that, and then compiling it. So once I have that, I can go back to my main activity, and in my second, I'm going to start my second activity. This is where I want to post the activity. So in my code, I'm going to get a reference to that second button. Let's call it post button so we're not confused. Of type button. Import that, and then find view by ID, r.id, and then you can just type in button and it should be down there. Okay, so once we get the reference, post button, set on click listener, and then, all right, so when I click on that button, I'm going to grab the text out of my text field, or to edit text, excuse me, and then post it. So let's get a reference to our text view. And that's going to be, again, it's going to be of type text view, and find view by ID, r.id, and we're going to get the edit text, just called edit text. Right, and then another value, because we always create our variables using value unless we need to mutate it, which is not as often as we create these values. This one is going to just be called message from text view, and that is of type string, and I'm going to grab that out of my text view .text, and you can see the text is of type character sequence, so you get a little squiggly, and just put that to a string, and that will fix it for the most part. Do be careful about pulling just random stuff out of text edit texts, but we've already covered that. All right, okay, so once I have that message, now I want to post it. So I'm going to say, hey, EventBus, and I'm going to import that, get default, if you remember, and then post. And then it says event of type any. So any is very similar to Java's object. It's just basically any type. So it's an overloaded method that we can post or send any class through this. All right, but we don't have a class yet, so I am going to instantiate one. I'm just going to call it message in a bottle. It's going to turn red. I'm going to instantiate that, just calling the constructor like this, and it turns red. And if I click in the red one, I should get a little red light bulb. So if I click on that, you can say create class message in a bottle, and then it's going to ask me, do I want to put it in my Kotlin file or my class as a subclass, or this one. So I want to extract it to a separate file, make it a little bit cleaner. Which package do I want to put it in? All right, so that's just an easy way to instantiate or to create the class. Let's go ahead and add that to Git. All right, so again, I showed you in the notes that you can add data to this. You can add members to this class and populate that with some useful data so you know something about what this event entails. And the way that we do this in Kotlin is we actually create a data class. And data classes are really nice because they're just what they say they are. They just contain data. And so if you denote data in front of the keyword class, and I put a constructor in here, as my constructor definition, I can create a variable. Let's say message in a bottle, and that's of type string. And that's it. So that'll create obviously a class, but it'll create when I instantiate this, it'll create a class with a variable called message in a bottle, but it'll also create the setters and the getters for me. I don't have to explicitly do that. The compiler does it if you want to set certain like read only and that fun kind of getters and setter stuff, you can do that. But this is just a really nice way of saying, hey, I want a class with one member or multiple members. Just do it that way. Okay, so there's our class, and then if we go back to our second activity, that stops being read. It's going to ask me to pass in a message. So that message is this guy, our message from text view that we pulled out of that text view, and we posted it. Now, if I ran this application, it would work fine. Nothing would break. There would be no null exceptions. As you see, there's no connection to my main activity. But in my main activity, I do care about that message. And again, this could be multiple activities throughout your application or other classes. And I'll give you a more concrete example at the end, but we're just going to go through this. Now, if you remember from the notes, we had to create a function to catch or subscribe to that. And before I forget, let me go ahead and you can do it. So if I hit Control O and do on start and hit down until you see it, it's kind of way down there on start. Oops, EventBus dot get default dot register, and then just say this. And then before you do anything else, before you forget, because I always forget, and that's just me personally, maybe you're smarter than me, I'm sure you're smarter than me. But again, before I forget, EventBus get default unregister. And this. Okay, so technically you could register another object for it if you wanted to, but most of the time I just use this. Okay, so one problem with this. This is fine. When your activity starts, you'll register, and then when it stops, it'll unregister. However, if your activity is in the background, meaning that second activity is on top of it, this will never get called. Your subscription, you'll never get notified that that event posted, because again, when your second activity comes onto the stack and on top of this main activity, then you've already unregistered. So what I like to do in some cases, depending upon your needs, is I'm going to actually keep this in here, I'll comment it out, and I'll put it in my onCreate. Now, this is fine because if I didn't unregister and I kept it in the onStart, you'd actually find out pretty quickly, because your onStart would get called multiple times, and then it would crash. It would say you can't register this object more than once. There's an exception in there, etc. But what happens is, and I'm not sure if this crashes, but if you call onStop twice or it gets called twice and you unregister twice, I'm not sure if that crashes. Never did that before, but it does. If you do register twice, it crashes. So I'm going to leave that in here just for illustration purposes. Control O to get our overrides, and I'm going to do on destroy. If you remember from our activity lifecycle, on create, on start, on resume, on pause, on stop, on destroy. So when this activity gets destroyed, that's where I want to unregister this. So on create and on destroy, because those only get called once per lifetime of this particular activity. And because this is our main activity, that's what we want. Again, depending upon your needs and when you need to know about these things, put it where you need it. For instance, when you come back to this activity, maybe that's where you want to go and check to see if anything changed. But anyway, we'll put it there. Okay, so we're in our main activity. we've registered for we've subscribed to that YouTube channel. In our second activity, we have the ability to post something and post that up using our button. And I think that is it. So again, we don't need to know anything about, oh, I'm sorry, I didn't actually implement the on event. I knew I was forgetting something. Okay, so let's do that. So we're registering it, but it doesn't have anywhere to go once it gets that. So from the code, you can look this up on the website. There's an annotation called subscribe, and it's going to ask for a parameter in that annotation, and it's going to be a thread mode. So I kind of mentioned this last class very briefly, just to I was showing you some random thing. But in our thread mode, when we get notified of this event, we might need to do this on a background thread. In our case, we're updating the UI, so we actually need to be on the main thread, or the UI thread as it's sometimes known, because what ends up happening, if you try to update the UI on the non-UI or non-main thread, you'll get an exception. Android will throw an exception, so you can't do that. So don't ever update UI stuff, text views, edit text, etc., on any other thread than the UI. So we want to make sure that this method gets called on our main thread. So we just do thread mode. I can type in here. And it's going to ask for a number of, like, okay, what thread mode do you want this on? So you type in thread mode dot, and you get some of the listings here. So the async, the background, the main, the ordered. It all has documentation if you want to read through it and figure out which one it is. But I do care about the main thread, so we'll keep that one. All right, so this is an annotation to a function. So we're going to create a new function. So fun, and then you can literally call this function anything you want. So you can say on message received, or simply on event is what they have in the documentation. I'm going to be a little bit more explicit and just say on message received. It's a function, as I mentioned, but it does take a parameter, so we want to have that type. And again, you can have different types of messages. So this one is the message in a bottle, but you might have one where a user has logged in and you want to post, hey, user successfully logged in, or they logged out, etc. So we want to have a event, and that is of type message in a bottle. So you can see we can subscribe to many different YouTube channels or events just by changing the class type that we're subscribing to. So I want to say I'm going to register myself as an observer, but here are specifically using these annotations. This is kind of where the magic happens. What event types I care about. And this annotation, again, just kind of registers with EventBus, hey, this is the message that you use to call back for this particular type. And it does not matter what you name your function. So you can have multiple functions with different names that have different event types, and it all just works. So load this up with as many events and event types as you want. All right, any questions so far? Kind of moving fast, but again, this is all covered in everywhere. I posted a video, it's in the notes, so just want to make sure this all makes sense. All right. Okay, so when we have this event, it's a message in a bottle, but it's our own bottle, so we know exactly what's in there. Namely, we want to pull out that message. Just going to call it message string of type string. And in our event, we have ta-da, message in a bottle. So you get all your members in your class. We're going to pull that out, and then as I mentioned, we're going to put it in our text view, which we don't have a reference to yet. So I'm just going to say text view of type text view equals find view by ID. You can see that I'm typing in find view by ID a lot, right? And I've only put in like 4 UI elements. There is a better way. I'm just not going to throw that at you at the moment. But yes, it does get a little tedious when you're just doing find view by ID, find view by ID. And then you got to remember what I even called the text view. I think I called it text view. Okay, so on our text view, text, and then we set that equal to message string, and that should just work. Okay, so a couple of caveats. In the video that I posted on Wednesday, I was using fragments, and this is kind of true sort of with an activity, but what happened with the fragment was it actually got destroyed, and so I was posting this as a class variable and getting the reference in my onCreate and then using that in my onMessageReceived in the video. So if you watch it to the end, you'll see the fix that I have for it, but what basically happens is it loses the reference to it. And so it's sometimes a good idea to recreate the reference here. However, I'm not really sure that the activity has been created. It should be created, but you never know. And so if you do want to make this a class variable so that it's not a local variable, you can, see if this will work, right-click on it, go to refactor, and you can extract it to a property. Oops, not a property, sorry. Where is it? Refactor, extract to a, I think it's just a variable. Okay, sometimes that works, sometimes it doesn't. I'm just gonna cut it out. I'm gonna go up to the top here, and I'm going to do, you can't make it a value because you have to instantiate it here. In this case, you can make it a variable. You're still going to get an error because what's going to happen is you have to instantiate it. Kotlin makes you instantiate, remember, variables. So what do? Well, we could just go the Java route and set everything to null, and oops, that's, yeah, well, okay, it did it for me. But it's like, well, you can't have these non-optionals be null because non-optionals can't be null because an optional can optionally be null or it can have a value. And by default, they're not optionals. So you can say, okay, make it an optional by putting a question mark in here, which means, again, it could be a null, and the compiler will enforce the fact that you need to null check that somehow. But we don't want to do this. You might do that for variables. But we want to use this late init keyword because what we're saying to Kotlin is, and I have to delete the null variable here. What we're saying to Kotlin is, yeah, we know that this isn't instantiated yet. I can't instantiate it when the class is created because I have to set this content view with my layout because my layout is what contains my text view. So I cannot do this in my declaration here. And so I can use the keyword late init to say, I'm going to initialize this later. And that'll get rid of your errors, and then we can set that to here. Now, if we try to use text view without instantiating it, meaning this line, then it'll crash, which is fine. If you were using an optional, it doesn't necessarily crash because it doesn't let you compile it. So there's a bunch of different checks. So use what makes sense for you. Kotlin gives you a nice wealth of ways to handle these, not just having to null check everything, because that's obnoxious. So most of the time I'll do this in my onCreate, but I just want to introduce you to late init because it's pretty useful. All right, so anyway, let's put some breakpoints in here just to kind of show you the workflow of this. Let's see if I can I'll put a log statement. So sometimes you cannot put a breakpoint on an empty function because the compiler just gets rid of that function because you're not actually using it. It's pretty smart that way. I'll just put something in here. So on stop, so I can put a breakpoint there. Log D, not bus though. That would be okay. Oops. Fat fingers on start. I hate this keyboard, by the way. If you get an external keyboard, like, yeah, go all out on your keyboards. This one's like crammed too small. All right, sorry. All right, so we got this one, and I'll just throw in on our create just to be fine. All right, and then in our second activity, I'll just put it in the post on the button when you post it, just to kind of inspect our our variables. So a lot of times when I write a lot of code like this, I will put in these variable, or I'll put in these breakpoints because I like to walk through my code, even though I kind of assume it works. I mean, I've done this a couple times already today in an app I was building, and then for preparation for this class. So I'm kind of know what happens, but let's put a breakpoint in. Let's go ahead and run it. And let's see what we think is happening is actually what happens, because in programming, okay, so this will get installed. This is our previous project that that was an example project. Still running. Let me go ahead and close this. It's funny because I told myself I should build this as I am, like just do a, if you go up to build and just do make project while you're coding, it'll save you kind of this little waiting period here. It does look like it's done. Sometimes it gives me an error and it doesn't really tell me, so. Oh, there was, well, that was, I got some warnings in there. It should be fine. Let's rerun this again. Sometimes it doesn't take the first time. Okay, yeah, for whatever reason, just rerun it. All right, so in our onCreate, yeah, sometimes it's not about what you know, it's just how to fix the bugs in your, or these little things in your IDE. It's like, man, this is not working. What's wrong with my code? It's like, sometimes it's not your code. Most of the time it is. Like, I won't. I understand that it's usually user error. Anyway, yeah, just rerun it. Sometimes you'll have to restart your emulator. Oftentimes my emulator will just flip out on me and it won't work, it won't whatever. Do a full restart on your emulator. If that doesn't work, do a full restart on Android Studio. Sometimes it just glitches and it gets stuck and I don't know. It's weird. Okay, so onCreate gets called. We're registering the EventBus. I'm going to hit continue through. All right, onStart gets created. We're just doing a log. Okay, great. So our activity started. We go to our emulator. Hello world, our button. So we're going to launch that second activity. Our first activity, as you can see, as I mentioned, gets stopped. Okay, so if we unregistered, we would never, this message, onMessage received function would never get called. So that's why I put it in the onDestroy. As I mentioned, EventBus keeps a list of all the subscribers, and so you just make sure you have that clean, make it clean. EventBus does not crash if you try to send a message to a zombie object or an object that doesn't exist anymore. So, I mean, yeah. Okay, so onStop gets called. Let's continue through that. Let's go back to our emulator. Let's type out our message. So, message in our bottle. Okay, and then we're going to post that. Remember, I'm keeping my button above the keyboard. That's kind of why I put it in a horizontal layout here. Post. Okay, so in our second activity, under the onClick listener for that post button, we're getting the text out of it. So let's step over that by clicking this little button here on the left. And now we can kind of investigate what our text view looks like. Most of the time, I'm really, when I'm trying to find a view by ID, I'm mostly concerned with the fact that it's not null. All this other stuff is low-level stuff that I really don't need to know. You can see the IDs right there, but yep, that looks good. All right, so now that I can step onto line 21, I'll step over that, and now I can see that indeed it did pull out the message correctly. You can see what type of text view it is, our support version 7, yada yada. Sometimes that's important if things aren't working. Okay, and then I am posting to EventBus. I forgot to dismiss the activity, so our activity is going to stay on the screen, but that's okay. So I'm going to continue through that, Now, sometime in the future, obviously it was like a millisecond or two, but that might have happened on a background thread. Maybe you were doing a bunch of work and you decided to post that event in a background thread. Again, this is making sure that this message that's coming back to our main activity is on the main thread because, again, when we're updating our text view, it has to be on the main thread. All right, so when we get this passed in, because we're in the debugger and I put the breakpoint here, you can see that event has a class message in a bottle. It has a variable message in a bottle, and that's set equal to, that variable is equal to message in a bottle. Perfect. Or message in our bottle. So everything looks good. I'm going to step over this line of code that's going to extract that payload data out of it and put it into our string variable. So you can take a look here. You can even drop this menu down and kind of do it in view, a little drop down, and see that I have a couple other, just basically inspect that class or that object. And right now our text view is null, but once I step over that, it looks good, and then I'm going to continue through this. Now if I go back to my emulator, you can see we're still on that second one. If I dismiss my keyboard and hit that back button, our activity manager will handle all that functionality and pop the second activity off the stack. So pop that off the stack. Goes back to our first activity. OnStart gets called, and we're starting the activity, at which point we would register. But again, we put that in the onCreate. And let's see, play through that. Go back to our emulator, and there's our message, and we can complete that cycle over and over again. So what this kind of did, and this is a very trivial example, is if you remember from our last class where we created those two activities just like we did in this class, we had to create an intent. We had to pass that. We had to put the data in that intent, and we had to remember what that ID was for that intent, both in the main activity and in the second activity, so that we could know it was basically a key. So what that key was in order to extract that data out. This one, it's kind of the same thing where we have to know what class we're caring about. And so again, this is kind of a trivial example. But as your application grows and you have all these different messages, say 20 or 30 of these things, you can see how this gets a little bit easier to manage than a whole bunch of intent keys for some intent bundle that you're trying to extract data out of. So namely, when you're working with the camera intent, you say, okay, I'm going to launch this camera, and then I have to know a whole bunch about the camera activity and what data it passes back through its intent in order to extract that out. That's a fine pattern. There's nothing wrong with that. But again, if you don't, the activity that's launching that camera is fine, but what if I need to know about that data in another class or activity? Then you can see that I'm now passing this kind of daisy chaining my data through to these different activities. So a better example, I promised you a better example, is a login, when you have to do login. So I have an app, and I want to make sure that before I open the application or display some sensitive data that the user's logged in. So what I would probably have is my main activity, just call it main, and then I have some kind of authorization or authentication, whatever you want to say, class. It's not an activity, it's just a class. It's a singleton, there's only one of it. And I say, in my main activity, I say, hey, authorization manager, let's call it, is the user logged in? Do I have an authentication token? If I do, maybe I pass it back to the main activity. So there's a little bit of an interface there, that's fine. We pass back the authentication token if we have an authentication token. And if I have the authentication token, then I display another activity, or maybe I show, populate the main activity with, let's say, a list view, because this will actually be one of our projects that we do. Not necessarily the login screen, but this. If I do not have an authentication token, or it's expired, because I should know that in my authentication. Like, okay, I get an authentication token and it expires in 24 hours. I check the time. I can ask the authentication manager, is it valid? It'll say no. Whatever the case is, however you do your logic, it's not logged in. So let me display a login screen. So there's username, these are edit texts, username, and password. So this is a really nice way of kind of laying out and defining which screen to show before the user comes in. So the user would log in, and then it would go back to the main activity, and the main activity would then launch the main interface. All right, so we could use the observer pattern here where I log in, I type in my username and password, and instead of passing the data back through an intent to the main activity, that main activity would then have to go to the authentication manager and then get a new token, and then that token would get passed to the main, and then I say, hey main, or hey second activity, you're logged in, go ahead and dismiss yourself, or however that works. That's really, really messy. That's the daisy chaining that I was talking about. Instead, from our login, let's login. Again, this is a singleton, so we can just call it outright, say, hey, authentication manager, here are my user credentials, username and password, do a login attempt. And then you can either have a callback, like a Lambda, if your language supports it, but with Android, you don't get the latest fancy Java functions or even Kotlin functions, or features such as Lambdas. So you might not have the ability to actually have a callback that gets called when that login is either successful or a failure. So we're going to use the observer pattern here. And so what you can do is, in your login, you register yourself. You say, I care about the login event. And you call authentication. You pass it the username and password. And then you just wait. Maybe you put up a waiting little spinner. Say, I'm going to wait. And I'm just going to wait. I'm done with my function. But again, I've registered for that notification. So I have a callback, let's say on login or whatever you want to call it. And we do the EventBus subscribe, blah, blah, blah. And we have an event called a login. And so in that event message, instead of just putting a string in there, you can put a Boolean that says, is that login successful or not? If it's not, maybe you put a message like why? Is it unauthenticated? Is it an invalid user? Is it the user blocked? Is it unauthorized? Whatever. So you can put some detailed message in there along with that Boolean value of whether that was successful or not. So in the logic for on login, that's where you can say, okay, it was successful, great. And you never have to, the login screen never has to know anything about the authentication. It just has to know, hey, if it's a failure, I'll get rid of this spinner and I'll display a message. Hey, username, password broken or incorrect, or whatever the message is, you can display it and let the user know what happened based on that event that came back in EventBus. Okay, so this is kind of still a trivial example. Maybe it's a one step up, a better example. But here's the thing. When I've logged in. On login was successful. I remove the login screen. It gets dismissed. It goes back to the main activity. Main activity launches our list or our main content here. And now you're in the app. You're communicating with the server or whatever you're doing. You're in the app, etc. That 24 hours of that authentication token expires. Now what happens? Every time you make a web call or a web services call, you're just going to get back invalid data. And you can handle that by again coupling to the web services manager or some manager that handles that communication, or whenever a call to your server fails, you post a message saying, hey, this is maybe I'm in another details activity here, I'm doing whatever, I have a bunch of different activities, fragments, whatever in my app. Maybe this activity is loading some content, and all of a sudden my authentication token expires. Well, these different activities or classes or managers or whatever these are, they can be listening to the fact, if they care about it, that the authentication is no longer valid. And so instead of, well, here's an extreme example. If you have an event queue, which is a design pattern, you just have a whole bunch of events that need to take place, and they're in a queue and they're waiting to get processed or worked on, and they all have to go out to the network. It's the ubiquitous cloud. So this is my network. Well, instead of saying, okay, well, this event gets fired off, I need to access to the network. Oh, that failed. Okay, we'll go to the next event. Oh, that failed because I don't have network access. We can get notified on all of these objects that we do not have network availability, and just don't do whatever you're going to do. Just pause or just stop. And so the observer pattern is used a lot in something called reachability. It goes by many names. Reachability. Okay, so reachability, we say, are you able to access the network? Well, is Wi-Fi on? Yes. Did it get turned on? Then I want to get notified of that Wi-Fi getting turned off. Did it get turned off? Did it get turned on? What does that message look like? So maybe there's a Boolean value in there. So if you ever, go to, I can write this kind of, my handwriting is a lot better than this you've seen on the board. But again, my network gets turned on, it gets turned off, or maybe my router, it's on, but I pull the plug and it doesn't actually have network access. I want to know about that in my application because I want to display to the user, and no matter what activity I'm in, that I just lost network activity. So again, this is a great example of the observer pattern where in any single activity that needs to know that has turned off, I can just subscribe to that event and handle that accordingly. And I could go on with examples, but hopefully that's clear. Is there any questions on that, or did that make sense? Okay, good. I kind of over-explained it because sometimes it gets lost on people or they don't use it. But I think part of the problem is a lot of people get a little gun-shy on actually like using it. It's like, I don't know, it sounds kind of intimidating and I have to install a third-party library. Actually, Android has this built in. I just don't use that pattern because I don't like the Android implementation of it, and apparently neither does Green Robot because they've reinvented it. But with the Android built-in one, I don't think they had, I haven't used it for like forever, but I don't think they had threading where you could define whether it was on what thread it was. It didn't have all these fancy features, but anyway, yeah, so I hope this is useful and you're kind of thinking about when you design your final apps, how you can incorporate this observer pattern. I'll throw a couple other design patterns at you, and maybe I'll just have a class on just design patterns and just go over them really quickly because they're really, really useful. Like, I'll give you an example, like state machines, where you have an AI agent, and the AI agent needs to have these different behaviors. You can have a pointer to a class and swap out those different classes for the behavior, and those different behaviors can be inherited from each other. So, for example, you might have one that's aggressive, one that's more defensive, etc., and you're just pointing to a class that implements a different behavior. It's the same exact class, it just has the inheritance of it changes the behavior a little bit, and by not really having to have copy and pasted code, you can just say, well, point it to this instance of that class, and all the behavior exists there. Or now point it to this class and have all that behavior in there. So if that's sort of interesting to you, you can look up state machines and how state machines work. But again, I'll throw a bunch of different patterns at you because they're really, really useful. And I'm a little disappointed that you guys don't know design patterns. But let me change that for you. Cool. So any other questions, either on the stream or... Cool. All right. I'll see you Thursday. Thanks for coming out, guys.
I think we learned like bits and pieces.
Uh-huh.
Because like we learned about